Hello everyone, I'm Siddharth. So I'm going to present smart navigation system for urban route optimization. So Chennai's rapid urbanization has created severe traffic problems. Existing navigation apps like Google Maps use generalized algorithms that don't work well here because they ignore narrow residential streets, metro construction diversions, seasonal flooding in Velachery, Tambaram or Porur, and complex one-way systems. So our project is an AI-powered navigation system specifically for Chennai. So we use OpenStreetMap road data processed with OSMNX and NetworkX and ML models using split learning and XGBoost for congestion prediction and full stack development with real-time traffic integration. So one of the major issues are large complex Chennai road network and unpredictable traffic and road diversions. Converting real roads to graph structures for algorithm and balancing algorithm accuracy with speed and creating a user-friendly interface. So one of the main paper is minimizing traffic congestion through continuous time route reservation. So this paper proposed reserving road segments in advance to prevent congestion. So they used MILP for optimization and Dijkstra heuristics. So what we improved are their system requires centralized infrastructure and pre-reserved routes don't work for real-time navigation and MILP is computationally heavy for large networks. And this paper detects incidents and delivers bypass strategies. So they focused only on incidents and no weather or flood adaptation. So general traffic models not Chennai specific. So we added AI-driven flood and construction avoidance. Also, we provide a multiple route comparison, fastest, shortest, and safest. So our system has four main modules: map and UI, routing engine, and AML engine and data management. So in front end, they have a user and admin interface. So in user, regular commuter can search location, view routes, and report incidents like potholes or waterlogging. So it admin, the system administrator who can validate reports submitted by users, manage accident hotspots, and send alerts to all users about roads closures or rain. So in ML engine, this is the intelligence behind our system. It has two main components: traffic predictor and safety analytics. So in traffic predictor, we use XGBoost algorithm to estimate delays and predict congestion with 75.5% confidence. So in safety analytics, we use DB scan clustering to identify accident hotspots and calculate risk scores for routes. So in external APIs, we use data sources, which is used for real-time data from three sources: TomTom API for live traffic conditions, and OpenStreetMap for road networks and bus stop location, and OSMR for route calculation. So in Fast API server, it is the core backend server. So it handles CRUD operation, creating, reading, updating, and deleting data, and fetching the real network graph for routing, and connecting all components together. So and we have database, which is a storage layer. So all our data is stored in Firebase Firestore, organized into collections. So incident history, saved routes, hotspots, and user data. So in incident history is reports of potholes, waterlogging, and accidents. So in saved routes, we have users route history for ML training. In hotspots, we have accident-prone area is identified by DBscan, and user data we have preferences and saved location. So in So, and we have a live scrapper. This is a module scraps live Chennai news and weather data to keep users informed about current weather condition, road closures, flood warnings, and traffic incidents. And we also have a routing engine, which is a core logic. This is where the route calculation happens. So ONM's ONX integration, safety weight graph, and multimodal logic. So we have interface which is connecting everything. So which is used for API requests between front end and back end, data flow between all components, and real-time updates to the user interfaces. And this is the project workflow. So this diagram illustrates the three-layer of architecture of our smart analysis system. At the top, we have the data sources. The system takes live traffic and map data from the TomTom API, real-time user and incident data from Firebase, and historical trip patterns along with past accidental records. So these three sources together feed into the middle layer, which is the processing layer and the brain of the system. So DB scan clustering groups nearby accident in location into hotspots, and the XGBoost classifier is trained to predict accident risks. Then the core prediction engine takes over. It performs a machine learning model interface to get real-time congestion penalty, predict traffic congestion using a gradient boosting model. So all of this happens in under 500 milliseconds. So finally, the bottom layer is the user interface output, where the driver sees the safety score for the route live congestion levels. So this is a system requirement and tools. So we use HTML, CSS, and TypeScript for structure and semantics, styles and responsive design, and core logic and interactivity. Leaflet.js for interactive maps, and chart.js for data visualization. So in backend, we use Python and Flask for handling API, routing logic, and front-end integration. JSON files and data Firebase for storing Chennai road network and landmark easily. For future user data and traffic based storage, and use GeoJSON for data format, which is used for enabling a map layer integration with Leaflet.js. And for API and services, we use OpenStreetMap for base map titles, and OSMR routing for road network data, weather API and geocoding for weather integration and location search. So thank you.